Hey there! Pretty sure all of you know this. The washing machine, laptop and grandma's old vacuum are all hooked up to the same outlet and all of a sudden, the fuse blows. You are going to learn why this happens right now. Today, we talk about Ohm's law and what a resistance is. Let's just start. You can think of resistance as the enemy of electric current. Imagine whenever the electric current goes through resistance, it slows down a bit. What is electric current again? Electric current is how many electrons go through a conductor within a certain time. And the voltage is the pressure that moves the electrons through the conductor. They are pushed from one point to another by it. The higher the resistance is, the lower the electric current gets. By the way, resistance is abbreviated with a capital R, and its unit is ohm. It's the Greek letter omega, this thing here. But what does a resistance actually look like? This thing, for example, is a resistor for engineers to tinker with. But actually, every electronic device is a resistor. More on that near the end. Alright, now we know what a resistance is. But what do we need it for? We will explain that now. Let's get to Ohm's law. What is Ohm's law? It's a physical law which was set up by another genius and his last name was Ohm. Sounds logical, right? And what does the law say? It says that there is a connection between the voltage V and the current I flowing through the conductor. Precisely, V and I are proportional to each other. But what does that exactly mean? If we increase the voltage in a simple electronic circuit, the electric current also increases. The higher the voltage, the more electric current is flowing. We can think of the whole thing like this. We have a small metal board. This is our conductor. Now we put a couple of marbles on the board, which are our electrons. They can move freely in any direction. If we lift the board up on one side, all marbles move in one direction, downward. That is the direction of our electrical current. And the electric current is equivalent to the time the two marbles need to roll down the board. If we lift the board up higher, the marbles will roll downwards faster. The height that we lift our board is the voltage in our electrical circuit. The higher we lift the board, the faster the marbles move. And the higher our voltage is, the higher our current is too. Now, we'll go one step further and put nails everywhere in our board. We can compare the nails to our resistance. We put our marbles on the board again and lift one side up. Pretty sure you can already imagine what will happen next. The marbles move downward but a lot slower. They are hitting the nails again and again, which slows them down. The more nails we put in, the longer it takes the marbles to get to the bottom. Meaning, the resistance is increased while the current is decreased. And that's exactly how it works within an electrical circuit. The electrons are slowed down by the resistance. This changes the electric current. And as always, we can put the whole thing in a formula, which is R equals V divided by I. R is the resistance. We know that V is the voltage and I is the current. And as always, remember this formula. And here is the magical triangle to help you remember this formula. Draw a triangle and write a V at the top and on the bottom R times I. If you want to calculate one of the values, you just cross out the respective letter and you will be able to read off the formula for it. Here's an example. We have a voltage of 10 volts and a current of 2 amperes. How big is the resistance? To calculate that, we simply take our triangle and cross out the R. Now, you can easily read off the formula. R equals V over I. Now let's substitute our values. meaning R equals 10 divided by 2, and this equals 5 ohm. Alright, that's how easy the whole thing is. Great, we covered almost everything, but there's one question left. What about the fuse? Why does it blow if we hook up all our devices to one outlet? We can easily explain that with Ohm's law. Every electrical device is a resistance because they need electricity to run. The voltage of an outlet in India is always 220 volts. Now we're going to hook up a couple of devices to our outlet. The voltage stays the same, but the resistance decreases. Because we have a parallel circuit of resistances here. The devices are not hooked up in a series, but parallel. That means we add up the reciprocal of all the resistances, which decreases the total resistance. That's slightly complicated. To understand that, just take a look at our video about series and parallel circuits. So now we have a stable voltage and a smaller resistance, which results in a higher current. Because if there are less nails in our board, the marbles can roll down faster. Eventually, the current reaches a dangerous level, so to avoid an overload, the fuse blows and all the lights turn off. Let's put this all in a nutshell. A resistance is the ratio between voltage and electric current, meaning which voltage is necessary to make a certain current flow through a conductor. Resistance has the symbol R and the unit ohm. Ohm's law states that voltage V and current I are proportional to each other. That means if we increase the voltage within an electrical circuit, the electric current also increases. And in order to calculate all these things, we just remember this beautiful triangle.